So good evening, friends. We'll start chapter 5, RT level 3. Question answer really. Study guide. The film radiographic process. Film processing, film speed. So you expose the film. And there is a film speed. So this is high speed, but after going somewhere it is slightly slower. Then the next one is slow. So film wise, slower film, log relative exposure. So exposure is higher and density is, you see here, for 0.5. So you need exposure more to get this density. So to get the two density here, if you see it is fast, then medium, then slow. So that is what is the film speed. Using the characteristic curve in figure 1, what is the exposure correction factor in film Z when increasing from 0.5 to 1.75? So if you see 0.5, about 0.7, 1.5, film Z means the first one. So it is coming around, say, so about 1.4. So 1.4, this is 1.75, sorry. So if you take it to 7.5, here it is slightly wrong. So you can take it to, this is for different one, sorry. Why I'm doing this. 1.575 is already there. It is around 1.5, you see. So 1.5 minus about 0.7 is 0.8. That's all. Antilog of 0.2 is 37.58. So being film radiograph, you have spot viewer, area viewer, strip viewer, combination of spot and area viewers. D is the density and incident light, transmitted light. So this is the, so this is a even example. Now this is for good high intensity viewer. How much should be? 3.427 candle meter square, 1 foot liter. the viewing radiograph in excess of 3 density. So you need this much power. So background lighting, although the viewing room need to be completely dark, no direct light should impinge on the radiograph being viewed except from the high intensity light source. Optical aids unit. Magnifiers. So interpretation aids, the reference radiograph is, you can take judging radiographic quality, image quality, radiographic contrast, is defined as the difference between the film densities of the two areas of radiograph. And definition, it refers to sharpness of the image outline. Focal spot size, source to film distance, and shape of specimen on the inherent film screen limitations, image sharpness. So these are the requirement. Film density 1.8 minimum for maximum X-ray, for gamma ray 2 to 4, and when being to superimposed is superimposing. Composite being, each film usually requires a minimum density of 1.3. Only subject contrast is the ratio of radiation intensity transmitted by two selected portions of specimen. That is film contrast and just go through this. Film definition. So this also go through this. Film contrast, film definition. Not going too much, just go as much necessary. UG equal to FD by D. All know this. So film unsharpness, also sometimes called inherent unsharpness, penumbra. Then you have artifacts. Artifacts are all these things. Pressure marks caused by improper handling of film and cassette. Say nail marks before and after. Scratch mark caused by fingernails and abrasive. Static marks caused by static electricity generated when film is removed rapidly from a tight container with humid humidity is more, then it will give screen marks caused by screen damage or contaminants with a chemical and sticks because of ineffective agitation of solution during development and rinsing. There is UG here in X-ray, and there is UC section 5. The same thing, sources and specimen thickness. As per specimen thickness, you have UG in inch. With this source, forget about this one. So then image quality indicators you already seen, but equivalent image quality indicators is there is a formula for equivalent IQI sensitivity. Alpha is the equivalent IQI sensitivity. Percentage 100 by x. X is the material thickness. Root over TH by 2. The T is the image quality indicator thickness, and hole is diameter expressed as a multiple image quality indicator. And this is like 1 1T, 2 2T, 3 1T, 4 1T, 3 2T. A root over B. Just remember that. I'm writing also. A root over B. So that is the formula. You follow that. And see that you can see yourself. A root over B by 2. One minute. It is, if it is B root over A, one minute. Let me see why I am wrong. We'll clear it. What I am looking. A root over b by 2. Okay, that's all. A root over b by 2. So you'll find the answer. A is first one and b is the second one. You leave it, just follow this. A is the first one, B is the second letter. 1, 2, 1, 4. So you'll get this one. Same data, the radiograph uses the same technique. For example, if 19 mm thick steel specimen were radiographed at 180 kilovolt peak, the exposure would be 8. And same data if it is 100 to 150 centimeter, 40 to 60 inch, resulting exposure using the source distance equation would be 18 mA per minute. So you have to calculate and see yourself. X-ray exposure chart allows one select exposure that will produce a specific density. In case this is figure 1, should be density is 1.5. If a different density desired, say 2.5, then the correlation factor must be calculated from characteristic curve of specific film being used. Figure 1. Okay. There is some printing mistake, I think so. If you go to figure 1, you can find this 2 and 1.8 and difference is 0.2. Let us go there. Is the 1.5. So get around 1.8. And here is the 2.5. Film, they should write film X. They're not written. Okay. So this what will happen until log of difference 1.8. So 0.2 until log of 0.2, that is 10 to the power 0.2. You will get 1.58. Therefore, original exposure 8 milliampere should be multiplied by 1.58 to give the correct 12.6 mA per minute for a 2.5 density. So problem, if 10 milliamperes for the exposure for density 2, what will be the exposure for 2.3? You can find out. So we'll solve one here only. The incident light intensity on a film is 30 units, log 30. Transmitted is log 30 by 1.2. So this is really should be bracketed. No, it will take. Okay. Sometimes if it will not take colors. So using characteristic curve in figure 1, what is the exposure correction factor for film shed when increasing film density from 0.5 to 1.75? Already we've seen that thing. 1.5 minus 0.7 is 0.8 until log 0.8, 6.3. In general, when using a composite film weighing technique, each film should have minimum density of 1.3. This also is same. If acceptable 2.5 density is obtained using 30 milliampere technique. When SFDF 24 inch, what would be the exposure time? 36 inch SFD using 5 mA to obtain the same film density. It is same like D1 E1 by I2 or D2 by D1 whole square. But this is for exposure. It should be increased. 36 by 24 whole square into 30 by 5. 18.5 minutes. Sorry, 13.85 minutes. The graphic presentation depicts the relationship between exposure and the resulting photograph density for particular film type. Is commonly referred to as characteristic curve. Those are all characteristic curve. Even figure A. Log relative exposure. H is denoted as H. This is density, so it is H and D curve. Okay, I'll stop here.